Good morning to everybody joining us today. On your landing page, you should see the instructions for participating in today's webinar. So a couple of sound checks. If you see my lips moving and you don't hear it, read on the form or on the landing page what you can do. For those of you that can hear me, welcome. It looks like it's going to be a nice warm and sunny day. So I definitely won't be standing up because I don't want you to see me in my shorts because I'm ready for the pool. So yeah, looking forward to this webinar with you guys today. So for all the newcomers, if you can hear me, then all systems go. If you've got any questions, we'll be doing the questions at the end. But if you've got a pertinent question that you're scared you're going to forget, just pop it into the chat. And we've got a full team running in the background that'll be able to either answer that or queue it for us at the end of the webinar. So I see the numbers are climbing quite nicely. Welcome to everybody today, and hopefully it's going to be yet another great webinar from Festa. So yep, 2 minutes to go, and then we're going to start promptly at 10 o'clock. So thanking everybody that's on time today. I know time is of the essence, and with us moving to level 1, more and more people are becoming more and more active at work, trying to catch up the deficit from lockdown. So thanks for attending today, and thanks for being on time. So we're going to start strictly at or promptly at 10. I don't want to say strictly because that's the dancing metaphor, strictly come dancing. Today, no dancing, but learning about disruptive technology. As we see the numbers climbing, welcome to the newcomers. Thank you for attending today. Thank you for being on time. We'll be starting in a few seconds time. So hopefully you can all hear me. If you've got any technical concerns, pop it in the chat or questions. So for the newcomers, or these that have just joined, we've got a Q&A session at the end of the webinar where we will then answer all of your questions. Even better, we'll take all of your order numbers because I'm sure once you've seen our webinar for today, it will definitely get those creative juices flowing. So it's 10 o'clock on the dot. I think we can start the broadcast, and the recording has started. All right, so it's 10 o'clock. Let's kick it off. Thanks to everybody that's joined us so far. Today we're going to have a look at the Festa valve terminal, referred to as Vtem. And today I'm being joined by my colleague Brett Benacada, EA application engineer from KwaZulu-Natal. And for those of you that I haven't had the pleasure of meeting in person, my name is Marcus Gericke, the head of electric automation for Festa South Africa. So what are we going to have a look at today? We're going to have a look at what we refer to as digital simplicity, digitized pneumatics, the Festa valve terminal, or the Festa motion terminal, which we passionately call Vtem. So what is digital simplicity? VTEM combines what we refer to as standard pneumatics with electronics and software to form a complete new and intelligent pneumatic system. This, of course, is characterized by complex movements, high functionality, status monitoring, and variable positioning. Don't forget reduced energy consumption, and all of this with very few parts. So, where to from here? So, first, the Motion Terminal, which we refer to as VTEM, is opening up radical new dimensions in the world of automation, as it's the first valve in the world to be controlled by apps. So it's the first product to truly earn the label of digital pneumatics for a wide range of functions that currently require over 50 components. So once again, digital simplicity. What does that really mean? All right, so digital simplicity means maximum flexibility combined with maximum standardization with minimum installation. So for the first time ever, the function of a valve can be changed by an app. So what does that mean? It means new intelligent technology consisting of pneumatics, electronics, software, and hardware is there to realize directional control valve right through to complex motion tasks. It also allows us to realize functions such as status monitoring, maybe reduced energy consumption with far fewer parts than before. In addition, some motion apps can automatically adjust to changes in parameters. So we know in standard pneumatics, if you have changes in atmospheric pressure or perhaps temperatures outside, compressor load, your pneumatics react differently. So that's why we say the VTEM is a true Industry 4.0 leader in digital pneumatics. So we mentioned combining mechanics, electronics, and software, and this is all brought on by the requirement of Industry 4.0. So Industry 4.0 represents another fundamental change in the world of production, where the real world and the virtual worlds are growing ever and ever closer, driven by the internet. So modern information and communication technologies are being fused with traditional industrial processes in what we call the so-called cyber-physical systems, thereby changing the value creation chain in many production areas. This global change, and yes, it's a global change, not just in South Africa, is taking place on all levels of the factory of the future. So digitalization will profoundly alter the world of production. A standard solution that combines mechanics, electronics, and software can become a cyber-physical system, with conventional objects turning into subsystems that have the ability to not only receive data, but communicate data. So all of that being said, where's the benefit for you as the customer realizing Industry 4.0? And of course, that's realizing the value-added benefits. So with the onset of Industry 4.0 or digital pneumatics, we can now include things like analytics, condition monitoring, and of course, all of this brought to you by cloud-based services. So by the likes of a dashboard, you'll be able to see the health of your machine. And of course, this introduces what pneumatics couldn't really do in the past, is introduce preventative maintenance. So this I refer to as a typical disruptive technology. So you might ask, what is disruptive technology? And disruptive technology is innovation that radically changes the way consumers act, produce, or consume in the industry of today. So we all go to work with a GPS, perhaps carrying a notebook, maybe the video cameras over the shoulder, your laptop under the arm, the old phone. And that is where we really see where disruptive technology really took over and changed the way people or consumers act or go about their daily lives. So for you that might not have seen, if you leave your life at home, which we refer to as the phone, you've lost all of those components. So that's a typical application of disruptive technology, where if you look 20 years ago, I can remember my fiance at one stage saying, I've got a laptop and I've got a phone. Why would I want this thing called a smartphone? That's back when BlackBerry was just coming in. So imagine where she is today, a Samsung freak, where everything is now in one form of technology. So you might ask, how do I combine this, or how do I draw this conclusion into industrial process automation? Well, it's quite simple. We have a look at the valve terminal. I'm going to put on my pointer, laser pointer. So if we have a look at the valve on the right hand side, we start to see that that one singular valve can replace up to 50 components. And those 50 components could be perhaps shock absorbers, proportional pressure regulators, getting rid of those nasty little flow controls that people love to adjust all hours of the night. So all of those are now being combined into a single valve. So once again, what is the benefit for you as a customer? It's reduced components that you need to keep in stock. It's flexibility that you've never had before. That valve has the ability to camouflage itself or change its characteristics by selecting an app. So my colleague Brett's going to show you a little bit later how you exactly change between apps. But imagine having one valve that can cover all of that, whether you've got a 5-2 way, a 5-3 center closed, 5-3 center open, or a 2-3-2, all of those in one. Over and above that, you can now, of course, include other things like proportional pressure, proportional flow, all of it through one valve. So let that sink in. One valve that will replace pretty much any valve that you've got in your factory. Sounds too good to be true. Well, let's have a look at how it actually does work. So on the left-hand side, I've got the motion terminal, one cylinder, one valve, and of course an app. Now the app, as Brett will show you, you can select either via PLC or bus to change the characteristic or the method that the valve is actually operating. So let's compare that to standard pneumatics. On the right-hand side, still the same pneumatic cylinder. We have flow controls, of course, pressure control, because we want to be able to do some form of energy saving or energy monitoring for you guys out there. So we'll have pressure regulators and of course standard 5-3 valve. So for those of you that might be like me that have forgotten what these hieroglyphics or symbols look like, let's relate it to our industry or your machines out there. So let's start by introducing the valve that you might see on the machine. So standard 5-3 bistable valve. So what do we do on machines nowadays? We need to control the speed of the cylinder. So we'll include flow controls. So remember, on these at the top, you'll have a little knob. You turn the knob, and of course, you're controlling the exhaust pressure from the cylinder. That will in turn slow down the cylinder, and with that, reduce banging, the mechanical wear and tear on a cylinder. So flow or pressure control, we add in two pressure controllers, and now we can control the pressure going forward and the pressure going back. You might ask me why? Because let's have a look at an application where we want to move a box. Let's say in a food and bev industry where you're moving a whole bunch of products into a box and then bring an empty plate back. You don't need the same pressure moving backwards as you do moving forward. So believe it or not, you can save up to about 70% of your energy consumption by being able to vary your pressures for your in-stroke and your out-stroke. But having two pressure controllers that are manually adjusted and locked is not really a digital way of controlling a system. So, or an optimized way of system. So let's have a look at changing those to an electrical control philosophy. So of course, with proportional pressure regulators, we can control that via analog, so perhaps a 0 to 10 or 4 to 20, or even IO-Link, we can control those pressure regulators. So now we can digitally, by means of a recipe, change the pressure. And if you include new electric flow controllers, you can now, by means of recipe, change all of those parameters to suit the machine. But have a look at that. That's 5 components that you need to look at. So we've got a valve, 2 pressure regulators, 2 flow controls, just to supply one valve. So the VTEM, let's compare what the VTEM actually can do. So you've got one component instead of 5. You've got one BOM, one bill of material that you need to size up or order. You've got one part that needs to be assembled, that needs to be maintained, that needs to be fault finded on. So you've got one spare part instead of 5. So look at what benefit that's got for your storeroom. So now your storeman only has to have one spare part instead of 5 different spare parts or 3 different categories. So that's where the VTEM really plays its part. So hopefully you can see that we've managed to reduce the parts. We've now given you flexibility, and we've given you all of this in one simple valve terminal. When I say simple, remember digital simplicity. So let's compare electric automation with standard pneumatics. And as you might know already, Festo has a full range of standard pneumatics, a full range of premium electric automation products, and of course, we're including VTEM as the bridge where we see our two customers, or our customers in two worlds, where some of them are so engrossed in the electric automation side, where they've converted the majority of their machines to high-speed servos, where they're looking at greater precisions, perhaps complex movements or variable positioning profiles. So that's all the benefits you get from a traditional servo system. Where looking at comparing it to standard pneumatics, it's a bit easier to operate. Perhaps the overload protection is of interest to you, or maybe because it's been in the industry for so many years, you deem it to be reliable and of course sturdy. So we've got on the two hands our pneumatic customers, we've got our electric customers, and now we put the VTEM in the middle, where of course we now get digitized pneumatics. So the VTEM is now giving us the option of creating complex movements without the need for servo pneumatics. So for those of you that ever had the I call it misfortune of having to set up a servo pneumatic system, you need high levels of expertise and programming background to be able to set up a servo pneumatic system. And it in itself, even though it was revolutionary in its time, has seen better days. So looking at the VTEM offering things like higher functionality, condition monitoring, do you see where the gap between standard pneumatics and servo, or standard servo technology, is now closed and bridged by digital pneumatics? So one of the key elements, of course, is the reduced energy consumption, but I think one of the biggest parts stand out is the fewer components. One of the applications that we'll take you through at the end of the webinar shows you how we can reduce big complex panels with proportional pressure regulators into one valve terminal. But I don't want to give too much of that away, because I believe you'll be amazed in what it can do. So how does the VTEM actually work internally? So without going into too much technical detail, each valve slice has 4 piezo valves internally. So with that, you'll be able to see that on your 2 working ports, output port 2 and output port 4, we have 2 piezo control valves. By adding in flow sensors and pressure sensors internal into the valve, we can control both pressure and flow to both ports simultaneously. So let's imagine a system where in the old days you wanted to lock a pneumatic cylinder mid-stroke with a 5-3 valve, and you would pressurize both sides of the port. Taking into consideration perhaps the wear of a seal on the cylinder, you'd always get creep to one side or the other. So with the onset of VTEM, or with the addition or the support of the flow controllers, we can actually monitor if there's movement in that cylinder and compensate by changing the characteristics of the valve to accommodate and force the cylinder back or to lock it in position. So that is in essence what the VTEM does internally. So it's combined your flow controls, your pressure control, the valve function, all of it in one platform. So where does this fit into your machine? Do you need just the VTEM? Do you need high-level PLC? Well, staying with Festo's ability to integrate into third-party networks and PLCs, the VTEM also seamlessly integrates into many field buses and of course the PLCs out there. So if it's Siemens, Allen Bradley, or perhaps Omron, we take care of the EtherCAT technology, Ethernet IP, Profibus, and Profinet. So you might ask, do you then require an additional PLC on the machine? So for smaller machines or standalone machines, you do have the option of including an onboard PLC based on the Codesys platform, and that you can of course do include it into the valve terminal and have additional IO, etc. So really flexible solutions depending on what applications. So one of the things that has always been asked is the VTEM designed for your rocket science type applications? And it's not. If we look at the majority of the applications, you'll be quite surprised in the basic applications that you can do, reducing complexity, reducing installation requirements, all from one single valve terminal. So if we look at the layout or the topology of what the VTEM actually looks like, on the left-hand side, you'll see where the CPX bus node module sits. So of course, there you can add your communication module, or depending on the amount of IO you need to control on the machine, you can have a code assist controller inserted there. On the CPX module, you can add in additional IO for the process logic, but on the right-hand side of the valve terminal itself is where the integrated IO is for the VTEM technology. So because of the speed that the VTEM needs to change parameters and adjust itself, the IO is directly connected into the VTEM module itself, and therefore we've reduced bus delays, snag delays, all of that to ensure the fastest and most economical adjustments from your valve terminal. So as you'll see at that point in time, we've got a sample of the 4 slice. So even though this is only 4 valves, each valve can be either 2 proportional pressure regulators, it can be 2 3-way valves, it can be 5-3, it can be a lot. So one of the applications, you'll see how we can reduce your installation. So standard configurations, we have a look at an 8-valve slice, the 4-valve slice, and the latest to be introduced is the 2-valve slice. So one of the other questions that I've always gotten is, do you have to have only VTEM valves if you've got basic applications like a flap where you just want to have it open and closed and you don't really care if it's controlled, you just want a basic valve? So with this, you can of course integrate standard valves into the platform. It doesn't have to all be that. So earlier I mentioned that the VTEM is controlled by apps. So how does that work? So if we look at our licensing department, and I say licensing department, I say it with a bit of tongue in cheek because it's not like the South African licensing department that never works. This one actually does. So the way it works is you've got access to your online shop. You then add in the Festo app world as your as a selection, then you purchase a license or an app. So with the valve terminal, there are several apps that come standard, and Brett is going to touch base on how these apps actually work or change between the valves. But what I'd like to bring across today is once you buy the app for the valve, whether it's a motion app or a pressure app, it stays on your actual valve terminal. So let's say in about 10 years time, you need to replace the complete unit for whatever reason. Let's say a forklift driver misjudged and he crashes into it. Your license can be uploaded, stored in our licensing department or our license central, and be downloaded to your new valve terminal. So it doesn't mean you have to reinvest in those licenses. So for each valve terminal, you will buy a license or an app, and that will of course be able to control. So a lot of the guys were concerned that they couldn't just take off the license, for instance, like old Windows, they can now put it onto a newer VTEM. So earlier I mentioned that it's not just for rocket science applications, it's for basic applications where you need better control, perhaps reduced complexity, or just better feedback from your standard pneumatics. So if we look at applications out there today, we look at pressure control, perhaps motion control, a combination of them all, or just standard flow. So in our applications today, we're going to have a look at proportional pressure control, where the valve terminal can actually go from vacuum directly into pressure. We can do blow functioning, we can do air knives, but we'll be looking at a curing press in the tire industry today, as well as synchronized movements. So all of these from pneumatics, which traditionally was, let me say, difficult to achieve. So with that, I think I've said enough. So before we go into the application examples, I'm going to introduce you to my colleague Brett. He was, how can I say, kind enough to do us a demonstration. So the demonstration is a recording purely to ensure that we have no buffering issues. So I'm going to start that and of course hand over to Brett for after that. So waiting for video. There we go.
Good day. My name is Brett Benakada, and today I will be taking you through an overview and quick demonstration of our VTEM or Motion Terminal demo case. We have a few of these around the country, so please feel free to contact your nearest sales engineer or application engineer for a face-to-face demonstration. So let's get the VTEM demo case set up and we're ready to go. To configure the VTEM, you don't need any special software. It has a simple web interface which you can access using your computer's browser through an Ethernet cable. So we will type in the VTEM IP address in the browser. And here we are presented with the actual configuration as a picture view of our VTEM. So let's click on the configuration tab, click accept. We have to log in to make any configuration changes to the VTEM. Here we can see these two valves here have apps assigned to them by these little icons over here. This valve is currently not in use or doesn't have an app assigned to it. And this valve here also has an app assigned to it. We can also have a look at the status of the inputs, and we can see the pressures of the exhaust port and the pressure port. We can also see the available apps that we have on this Motion Terminal. Here are all the apps that are currently available. Here's how many licenses are loaded onto this specific Motion Terminal, and here's how many are actually available for use. Some apps are available across the board, so when you purchase the app, it is available to all the valves simultaneously. Some apps are per valve. So if you have one app available or one app loaded to the VTEM, that app is only available one at a time. So you can load it to valve number 1 and you can use it there, but while it's used by valve number 1, it cannot be used by valve number 2, 3, or 4. So if you would like that app to be used in more than one valve at the same time, you will need to purchase 2 of those apps. Right, so to configure the valve, we click on it, and currently we can see that this valve has got the app assigned selectable pressure level, or the eco app, where you can select the forward pressure and the backward pressure to save air consumption. We are going to unassign this app by taking control. Alright, so this takes control of the higher order PLC. Now we have control of this valve from this web user interface. We're going to unassign this app. Now you can see there's no app assigned. So here we can see valve number 1 is connected via these pipes over here, and if we trace them back, they run to this cylinder over here. This cylinder has a spring on it, and the idea of this demo here is to show you how the proportional pressure works. So let's set that up. So let's find the proportional pressure app. There we go, proportional pressure regulation. We're going to click on that. We're going to assign that app to that valve. Okay. And it asks you for some basic parameters of the application. Now, the proportional pressure regulation app doesn't require too many parameters other than a rough estimate of the volume that you're controlling. Here you can see it's just a small, medium, large, or customer specific. But basically, anything below 0.1, anything between 0.1 and 1 liter, and anything greater than 1 liter. This cylinder is somewhere between 0.1 and 1, so I have selected the medium volume. Right, now we can start testing. I'm going to start the test run. Right, now the current status is port 2 blocked and port 4 blocked. Port 4 is currently connected to the back of the cylinder. Port 2 is currently connected to the front of the cylinder. So in theory, if we add pressure to the back port, the cylinder is going to move forward. Right, so let's make both ports active. Since we can control the pressure on each port simultaneously, we make them both active, and Currently we have a set point of -1 bar. Let's just make that 0, roughly 0. And if we then go and add a pressure greater than that, or greater than 0, we can actually see the cylinder starting to compress the spring. And as I slide the slider back and forth, we can see higher the pressure, the more that spring gets compressed. Okay, so proportional pressure control. Now you can control the cylinder as you would in any application, just forward and backwards movement. Okay, but you can set the forward pressure and the backward pressure. So that's a basic demonstration of how the proportional pressure regulation app works. Okay, so let's move on to the next valve. The next valve here, number 2, it is piped up to port 2 and 4 over here to the second cylinder. It's just an open-ended cylinder with 2 limit switches. We're going to assign the app called presetting of travel time. So let's select valve number 2. Let's select this presetting of travel time. Right, and assign that app to the valve. And what this app basically does is it asks you for the travel time to get from the retracted stroke of the cylinder to the advanced stroke of the cylinder. And it will then actually automatically set the throttling of the cylinder to get that exact speed. It does a few cycles, maybe 2 or 3 cycles, and by then it has already calculated the throttling position, and then from there onwards it's just making minor adjustments to maintain that speed that you've asked for. So we've put in a value here of 2 seconds for advancing and 0.5 seconds for retracting. Okay, so let's push the start test run button, and we're going to change the app control mode into commissioning, which is basically going to cycle it forwards and backwards until it reaches the desired flow control positions. So it's going to cycle the cylinder forwards and backwards. It's not going to be perfect for the first few cycles, and as soon as it gets into its dialed position, it's going to store that value for you, and then you're ready to run. So now you can see it's saying tune trajectory. Here you can see what the actual travel times are. Okay, so it's happy now. So if we do some tests, we're going to go advance. So that took 1.8 seconds. Retract. That was pretty much on target. Go back and forward a few times. The system is continuously compensating for any changes in pressure, changes in temperature. And you can see every time I go back and forward, the forward stroke takes about 2 seconds, and the stroke back takes about half a second. And that's what the presetting of travel time does. I would also like to show you the Selectable pressure level app. This is one of the eco apps to save energy. Let's enter in some parameters here. Right, so this is just asking you for the size of the cylinder, some length of tubing and diameters of tubing. We can save a lot of energy by dropping the pressure of our application. And we might not require the full force of the cylinder that we are using. Okay, but yet we're still running at 6 bar because that's just what the whole machine runs at. Now, by dropping the pressure on that cylinder, you're not filling the whole chamber of the cylinder with 6 bar of air. Now, for example, you're only filling the chamber with 2 bar of air. That saves a significant amount of air volume. Now, what we're going to see here is when we drop the pressure level, the speed actually won't change. Speed is determined by the flow of air going into the cylinder, not the pressure. The force is regulated by the pressure. So if we advance the cylinder, okay, we've set the air supply pressure during travel to 2 bar. So when it reaches its end position, it builds up 2 bar inside the cylinder and then closes the valve. You can see here we've only built up 2 bar of pressure. And when we move it back, again, builds up 2 bar and it stops supplying pressure. So this here is the speed of the cylinder, so this would basically mimic your flow controls of your cylinders. Let's make this quite fast. If we go advance and retract, you can see that is quite fast. And if we had to drop it down to 1 bar, you can see how the cylinder hasn't actually slowed down. And we can go right up to 4 bar. And the cycle time of the cylinder doesn't actually change. But what we can see running at 1.5 bar, we are using 33% of the energy we would if we were running at 6 bar. And if I up the pressure to say, let's just go 4.5 bar, and I start doing this, I'm now using 72% of the energy if I was running at 6 bar. So just by dropping the pressure from 4.5 down to 1.5, I'm saving a lot more energy, but I'm still getting the same cycle time. Now, this is only applicable if you don't require the force from the cylinder, but in most circumstances, we're only using the force of the cylinder in one direction. And there are other apps that allow us to set the force going forward and set the force going back, where we can save an insane amount of energy.
Awesome, thanks, Brett.
Thanks,
So,
Marcus.
I'm sure you guys will have noticed that there wasn't massive programming that Brett had to do. So Brett, correct me if I'm wrong, that's all just via the web interface, selecting a couple of parameters, making life a lot easier for the guys.
Yes, exactly. Very simple user interface, and also very easy to change between apps. And obviously, if the valve terminal is connected to a higher order PLC, you can change between apps on the fly.
Okay, so they don't have to physically log on every time. So let's say between a recipe, they wanted to change force to speed. It's a matter of just a signal from the PLC.
Yeah, you can actually change the apps per cycle. They pretty much change in real time. So you could change force control moving forward of the stroke, and then back of the stroke, you could move to flow control. So you can pretty much change the apps at any point in time in real time.
Awesome. But that's enough from my side. I think let's take us through your application that you're busy with there, and then I'll be back later on. Thanks, Brett.
Thanks, Marcus. Okay, so these are 2 local applications that I have worked with recently with the VTEM. And I've chosen them specifically because, as Marcus mentioned earlier, the VTEM isn't for your space age applications or very high-end applications only. They actually solve very, very simple problems as well with major benefits. So this application here was at one of my customers that build machines or packaging machines. And this part of the machine is actually the bottle cap unscrambler. So as we can see in the picture here, put my laser on, we can see in the picture here, we have the cap unscrambler bowl. And these cap unscrambler bowls have a series of air jets. These air jets assist inside the bowl in actually turning the caps over or rejecting the unwanted caps. And the air jets are set according to the type of cap. Now, this machine had 17 or 16 different cap variants. And depending on the caps that we're running in this unscrambler, you had to go and adjust these 4 individual flow controls. Now, the changeover time between each type of cap or each variant was quite long due to the fact that setting these flow controls was a bit of a trial and error process. Now, with the VTEM, replaced this bank over here, this bank of flow controls and this pressure regulator here. So the solution was the VTEM, and the benefits were basically as follows. So as Marcus mentioned earlier, the VTEM could have 2 pressure zones per valve, which means for this application, we actually only needed 2 valves. So that gave us 4 pressure zones. The VTEM application was only 15% more cost than this current solution. It was 75% more cost effective than the closest equivalent solution. So we have actually looked at digitizing this actual process of the machine quite a while back, but with the current solutions available then, it was just too expensive. And as you can see, 75% more cost on this was just not feasible. So the air jet settings now actually change with the recipe. So when the guys do a changeover on the machine and they select a new recipe, all the air jets are set according for that cap and you're ready to go without any manual adjustments. And all in all, the whole system just became much more simpler to mount, much less piping, much less drilling, screwing, fittings and tubing. So in a whole, just time saving as well. The second application was for a multiple pressure zone. And in this case, 12 different pressure zones for a spray nozzle on the end of a robot. Now, these spray nozzles require quite precise pressure control. The pressure actually controls the force of the paint and also the shape. There's all these jets that actually control how the shape of the fan of the paint comes out of the nozzle. And depending on the recipe, again, depending on what it was spraying, these shapes had to change. So a few years back when VTEM wasn't available, this was the solution that was provided. We have 12 of our VPPM proportional pressure regulators, all controlled via IO-Link. As you can see, it's quite a large enclosure. We need quite a large PLC with all the IO-Link masters on them. And there's a lot of fittings and piping and wiring. This was recently changed out by a VTEM. And again, we only needed a VTEM with 6 valves because again, 2 zones per valve, which gave us 12 independent pressure control channels. It was 60% more cost effective than the current solution. The pressure control, because of the way that the VTEM controls the pressure using its piezoelectric technology, was better and thus gave actually a better quality paint finish on the end product. It was much simpler mountings, fittings and tubing again, big time saving. The panel was 75% smaller. Again, space saved and time saved. So this whole panel here was simply replaced by a VTEM in this row over here, and basically everything below here was completely negated. So those are the 2 local applications I've done. Again, guys, this VTEM can solve really, really simple applications. Don't think of it as only for really high end or high speed or only its Industry 4.0 features. Obviously, together with those 2 simple applications, the machine gained a whole bunch of benefits like leak detection, energy saving, etc., etc. Those just are benefits that come with the VTEM. All right, so I'm going to hand over back to Marcus. He's going to take you through some videos of some other applications that have been done around the globe using VTEM.
Thanks, Brett. Yeah, it's amazing to see how being able to adjust between a recipe and manual adjustment. So Brett, if you'll make me a presenter again, just speeds up the machine, and therefore it really makes the life of the OEM or the customer a lot better. So hopefully you'll be able to see my screen again, and we're going to have a look at some of the applications that Brett has started to introduce. So we kick off just as a reconfirmation of what we did with that system. So that whole panel, a lot smaller and installed with VTEM. So if you look at an application where we perhaps dispensing, so this application that we're looking at here is dispensing of solder paste, and looking at today's gluing applications where you often have an expensive medium that needs to be applied to a certain area. By being able to control the pressure and the flow of the air, you can control the bead size and the forming. So in an application like this, we got higher process reliability, and of course reduced consumption of the solder paste, which in turn really gave the customer good energy saving and good cost saving. So the next application we're going to have a look at is one a bit closer to home, one that we've done in the tire industry. So on this, I've got a video to play to show you guys where the benefit. I believe if you see, it's easier to believe a video than me just talking to you. So once this video over here plays, if you notice that both of the machines are given a signal at the same time, but if you notice that on the right hand side, that arm took quite some time to get into place. So the interlock, of course, there's delays. Plus with the mechanical jerking on the system, that creates mechanical wear and of course creates what they call as shock on the system. So if you look at hydraulic hammer or pneumatic hammering, that's what happens with a system like that. So you'll see that the cycle time is quite long because they have to wait for both axes to get into position. The vibration has to stop, and only then can the rest of the process take on. So after we put in VTEM, it of course improves. So now try and have a look at the process. You'll see that both systems went in simultaneously, equally. Process started a lot faster, a lot less vibration, and all of that gave the customer an overall energy saving and of course cycle time reduction. So as soon as that video is finished, you'll be able to see that both of those axes, it looks like they're being controlled by servos. They're that accurate. So as you see coming up, nice and controlled speed, no vibration on that system whatsoever. Awesome. So if I go back to the presentation, you'll see that the customers saved around about 60% in energy. And as you know, energy consumption or pneumatic is one of the most expensive mediums that we have for motion at this point in time. And of course, 33% cycle speeding or cycle improvement over a production day can equate to quite a massive saving for a customer. So if we look at an application like synchronization, who of you have ever tried to synchronize two cylinders? So in the old days, they would cut the pipe in the same length and make sure that they're the same distance from the cylinder and put it on the same valve. And then you pray that both cylinders have the same wear and tear on the actual seals, because that is what's going to cripple that synchronization. So even on slow speed, I'm going to show you how to synchronize. All of these screens popping up, gets confused on a Friday morning. So trying to synchronize a pneumatic system on slow speed, you normally get introduced to what they refer to as stick slip, where of course those cylinders start bouncing around. And with the VTEM being able to control the flow and pressure on both ports to high accuracies, you can now synchronize pneumatic cylinders. So negating the need for perhaps a stepper or a servo solution. That's not necessarily just for, of course, slow applications. It's also for fast. So same application, just by changing the parameters like you saw Brett did, we've been able to change the cycle time of those cylinders, still staying synchronous. Awesome. So the last one that I'll be looking at, I don't have a video to play, unfortunately, because we're limited by GoToWeb, is applications where you perhaps have heavy loads, where you don't necessarily want to go into the cushioning of the cylinder because that would slow down cycle time. So by introducing perhaps an analog position sensor, you can have heavy loads moved up and down on a cylinder, but because of the control between port 4 and port 2 being so precise, we can lock that cylinder in position without going into end caps and cushioning. So ladies and gents, from my side, that's the VTEM in a nutshell. I'm going to open the floor now to Q&A, so a couple of questions, or if you've perhaps got some order numbers, I prefer those. If not, remember, we're more than welcome to give us a shout. We will then send an application engineer alongside a sales engineer, come visit you, have a look at your application, perhaps bring one of the demo units and show you in person that it's no magic, no trickery, it's legit digital pneumatics. And like I said, Industry 4.0 revolutionized with this type of control. So from my side, thank you very much for attending. From my colleague Brett, you can unmute, and from your side say the same, and we're going to open up to question. So I will unmute everybody. So if you'd like to unmute yourself, perhaps send us some praise and thanks, or perhaps a question, please feel free to do so. I saw there was a couple of chats in the communication. All right, so for a customer building multiple specific machines, can the parameter recipe commissioned on the first machine be copied to different VTEM terminals on each machine? Yes, it can be done. So the nice thing about having the configuration files, you can preload that. So of course, reducing the cycle or the time required to do the installation or pre-configure your VTEM. So very nice question.
Also, Marcus, sorry, can you hear me there?
Yes, and I can hear you, Brett.
To add to that question, obviously each machine will have its own unique pneumatic characteristics. Like you mentioned earlier, each cylinder might have its own friction factor, and also each VTEM valve is actually slightly different from one another. It might have different flow characteristics, etc., etc. Each valve has actually got its own memory of its own self as it runs, and as it slowly starts to wear in and the seals start to become a bit more less friction, or whatever variables I play, it's actually continuously just recording how the valve moves as its life progresses. So if you had to take that valve off and move it onto another machine or replace it with a new valve, that information is stored and actually moves along with it. So when you have multiple machines, they all have their own signature, but the settings that you give to them should be 100% identical and should give you the same result. So they really have thought about that and how all those variables that come to play with pneumatics.
Awesome, thanks, Brett. So you can see Brett has had fun commissioning these systems, and it's all a matter of playing with these toys. All right, floor open to anybody else there. We see you still got a couple of attendees. Don't be shy, ask away. We'll give it another minute or so, just waiting for all the questions to come in.
I see we have another question there. With locking a cylinder mid-stroke, what happens in an ESCOM load shedding state? So the valves in the VTEM are all normally closed. So theoretically, the cylinder should stay where it is. And they're spring loaded, so they'll always go back with no power. They'll always go back to their default closed state. However, if the machine would need to be still rated, you would need to have a zero energy valve, so the air would actually need to be dumped, and you would need to put a locking cylinder or a locking mechanism on the cylinder to prevent it from dropping down. That would be the proper still rated safety solution, but in your normal standard solutions where maybe humans can't be affected, the cylinder would actually stay where it is.
Awesome, thanks, Brett. We have a question now that says, VTEM bought by a machine builder with a license. How does the license get transferred to the end user? Do you know on that one?
So, Errol, a license is not something that you can actually quote on. For example, as a line item on one of your quotations, then your customer sends you an order number, and then you send him the license. Remember, the license is not a physical thing, it's just a key. The user or your customer has to log on to the app world, right? He has to purchase the license there, where then he will be able to download and manage his own licenses. Licenses are not something that will ever be managed by an application engineer or a sales engineer from Festo. It is managed by the customer themselves through the app world license portal. Okay, so you can include, when you purchase a VTEM, you can include licenses in the quotation or as part of the configuration of the VTEM. So when the VTEM gets delivered to the customer, it will already have those licenses preloaded onto his VTEM, and they will also have a record of that on his App World portal. If he wants to buy more, then you would have to do that using the App World only.
Awesome, thanks, Brett. All right,
Brett,
any other
Brett,
questions
can you hear
then?
me?
Yes, I can hear you,
You
Errol.
can.
Sorry, my question was, let's say an OEM is building a machine for us, and he's obviously purchased the license together with the VTEM, and now he's going to sell that machine onto an end user. What happens to that
Mhm.
license? Does the end user need to buy the license as well, or does the license get transferred to the end user?
No, I think in that case, for OEMs that are building machines, the license will look. The license sits on the VTM, so now that the machine is in the end user's hands, the license theoretically belongs to the end user. But the OEM will always service the machine. Hopefully, will service the machine and maintain the machine. So generally speaking, your OEM will also hold backups of softwares, backups of configuration. So theoretically, they'll be holding backups of licenses. So I think it's in the onus of the OEM to manage the licenses and never really transfer them over to the end user. I don't think that's possible.
Okay, no, that's cool. Thanks.
Cool.
A good question. Thanks, Errol. We'll
Thanks, Errol.
definitely check into that for you and maybe perhaps send an internal communication as well.
Thanks, Marcus.
Awesome. Any other questions from the field? Just give it another couple of seconds. All right. So if there's no more questions from my side, I'd like to once again thank you for joining us today. Hopefully we've planted a seed of the VTEM with you, showing you that the VTEM is revolutionary, but it's there for most of the applications that you get outside in the industry. So from my side, thank you very much. From my colleague, Brett, thank you for your input today, and for
Thanks,
everybody
everyone.
attending. Thanks so much and enjoy the rest of your day.
Cheers.
Bye-bye.